I wanted to provide an update for the LightShip PowerBoost combination to do both in motion and static charging of the LightShip battery. So what we have here is a variation of vehicle to vehicle transfer of energy. In this case, it's one way, not two way. It's AC and not DC. But we have a Ford F-150 PowerBoost that has an integral hybrid module between the engine and the transmission. It's about 10 inches wide, and it's a electric motor and a generator all in one unit. And it can take up to 30 kW of power to be a motor or a generator, and maybe even higher in the generator mode, but Ford restricts that somewhat. The innovation here is that there really are only two vehicles that fit this situation of having the ability to charge from the vehicle to the RV and do it in motion and statically. The in motion part is entirely novel. I'm not aware of any other RV that can charge in motion, much less a 77 kW battery. And it does it at level 2 loads, moderate level 2 loads from the generator. This is unique, and the only way it can really be done in motion is if the charge port for the trailer and the charge port for the truck are in close proximity. Many trucks have a output if they have a generator somewhere else, and if it's an EV, you're going to be just taking battery charge from one vehicle and putting it in another, rather than converting gasoline to electricity. So for this setup, what we have is 31.5 gallons of gasoline, which is roughly equivalent to 230 kW of electricity once converted through the PowerBoost system. And what we're trying to do here is take advantage of that supplementary power to not only charge the LightShip, but charge it in such a way it's passive. In other words, it's not being charged actively, it's being charged when you drive, when nothing else is going on. There's no need to stop at a DC fast charger, because this thing just keeps charging, and it charges whether it's in motion or whether it's standing still. The fuel flow rates are different between the two, almost unmeasurable in motion, and about 0.8 to 0.9 gallons per hour statically, sitting in a campground just charging the camper. So that's the background, and this is the configuration, the current configuration. This is about revision 5 of the in-motion charging configuration. And the configuration starts with the EBSE. And the EBSE in this situation is really important. And I'll move inside here to show that configuration. The EBSE that is being used for this configuration is a electron level 2 charger, but this is not like the Tesla mobile connector. The Tesla mobile connector is a lightweight mobile connector that at most can do 32 amps because it uses smaller grade wiring. And I'll get into the reasons why that's a problem for a mobile application. But the, the electron level 2 can go up to 40 amps, though we can't support it from the PowerBoost. Most we can do is 30. And nominally we run about 24, just not to strain the system. But this charger has 6-gauge wire. The Tesla charger has 8-gauge wire. Now this EBSE is also Wi-Fi enabled, so you can actually monitor what's going on back here in the bed of the truck as it sends power to the LightShip. So we're using an upgraded EBSE, and the principal reason for that is we lower the losses going back to the LightShip, but we make it more thermally tolerant to high temperatures that might exist in the summertime, where other chargers like the Tesla mobile charger begin to derate if they get hot. And they can get hot by sitting in the sun. They can get hot by sitting in the bed of a truck You name it. If it starts going above 105 degrees, they begin to derate and they'll shut down about 122. This charger, particularly running it at 24 amps with 6-gauge wire, does not, so far in my hands, derate. So it's a much better fit for the PowerBoost LightShip combination. To install it in the truck is a very minor modification. There's only one thing needed to conform it to the truck, and that's right down here. You'll see a 1 3/4 inch hole with a grommet in it, if I can get it focused, right down here, that goes down underneath the truck. And that is to avoid running it over the back of the bed or over the lift gate in the back. It just makes it a more convenient connection. This is the PowerBoost Pro Power on Board connection center, and the green plug is a 30 amp 4-pin plug that converts to a NEMA 1450 that goes into the EVSE. And it's all sucked up against the wall. It's an aluminum wall. The floor of this truck gets hot with exhaust and in motion. And so I had to get the EVSE up off the floor so it doesn't derate at high temperatures. So it's up on the side panel here, and I have a topper here with lots of ventilation. So I think we can keep the EVSE cool. So that's the internal installation of the EVSE. The 6-gauge wire goes out through the bottom of the bed of the truck, and it comes out conveniently through some already provided holes, which are hard to see here, but it's right here underneath the lift gate. And the wire runs along, and it's pinned in several locations across the hitch in a place where it can articulate. Excess wire is coiled up here, and then it runs across and is hooked into the only other modification for this system with a LightShip, and that's, in this case, a carbon fiber door with an access hole so that it can provide power in motion. And tying this down is critical, but luckily, the NACS connector has an electrical lock on it. So anytime the NACS connector is in, it's locked in. It can't fall out in motion. And I've done a lot of testing with this. That just works. But the other challenge here is to make it so you can take it off quickly when you hitch and unhitch. And that's taken me several iterations. You have to satisfy two needs. First, you have to have a robust installation that anticipates moving down the highway at 70 miles an hour and not falling out. So it's pinned in several places, and then finally the next connector is pinned. But that's the in-motion application. There are two applications to power the LightShip. One is in motion, but the other one is at the campground. And again, this is a functionality that very few, if any, other combination of tow vehicle and RV can match, because in this case, you can level 2 charge the LightShip statically. You do take a hit on fuel efficiency with that. It takes around 0.8, 0.9 gallons an hour at 5.6 kW, but it's far better than the alternative. And the alternative with an EV or any other ICE equipped vehicle that doesn't have a generator is there is none. You can't charge at a campsite. You can charge the LightShip at a campsite. It's not as efficient as it is rolling down the highway, but it's sure better than nothing. Also, for unhitching, when you want to unhook it, there are just a series of pins here around the whole installation. So you just unhook the cable, and then I've included a Tesla bag right on the back of the bed, or the uh, cover over the bed. And this opens is in such a way that you can open the bed door, or you can have it, I won't do it here, but you can have it come down as well, and it doesn't interfere with either the cord or the bag. But once you get to the campsite, you'll disconnect If you want to disconnect the trailer, you disconnect from the clips and then just coil it up inside the Tesla bag, and it just rides on the back of the truck until the next time you need to either charge the LightShip at a campground, or you want to reinstall it again to do in-motion charging. So this is it. This is the current installation, and this is how it would be going down the road, just like this. And we've done a fair amount of testing on all this, and I think we're very close to a final design to make this as user effective as possible.